As we calculated the 18 kilowatt, the solar charge controller capacity is around 18 kilowatts and the standard is 230 volts. This is solar charge controller. The capacity of solar charge controller is 18 kilowatts, 230 standard volts is there. From there, the cable is going to the inverter. So this is the inverter. The capacity of the inverter is totally depend upon the battery size. Battery capacity is calculating in a ampere per hour. For example, 10,000 ampere hour, 2000 ampere hour, 3000 ampere hour, multiple ampere hour is applicable. Select the battery cell capacity accordingly to your backup needs. For example, I required the battery backup for 18 kilowatts. So my battery size will be 18 kilowatts accordingly. Now how to size the inverter? This is the inverter required for solar electric panel. Inverter sizing is very important part. An inverter is used in the system where AC power output is needed. The input rating of the inverter should never be lower than the total watts of appliances. The inverter must have the same nominal voltage as the battery. For standalone system, the inverter must be large enough to handle the total amount of watts we need using at the one time. The inverter size should be 25 to 30% bigger than the total watts of the appliances. It means our requirement is 18 kilowatts, so the inverter size may be 30% more. For example, it must be around 24 kilowatts. For example, if my kilowatts is around 18 kilowatts, if I required the 30% more, so 18 multiplied by 1.3, it is around 24 kilowatts. So my inverter size is around 24 kilowatts. So that I will calculate the inverter size 30% more than the required power. In case of appliances type is motor or compressor, then the inverter size should be minimum 3 times the capacity of those appliances. Because in a motor there is the torque load, and at the starting point the torque loads take the double or triple power of the normal power. That's why the inverter size at the time of selecting the motor and the other size, we required triple time capacity of the normal type. So this is how to design the inverter sizing. For example, if my entire load is around 18 kilowatt, so my inverter will be 30% more, that is 24 kilowatt. Now the inverter requires the battery. So the inverter requires the battery. Battery cells are connected into the series like this. This is the battery required to save the power. Battery bank is something like this. There is the multiple rack available into the battery bank. So into the multiple rack we can save the battery accordingly. So this is the battery bank. Inverter saves the power into the battery bank, and then we can use the battery as per our requirement. Battery capacity calculating as per the total demand required for per day. How to size the battery bank or how to size the battery? The battery type recommended for using in solar PV system is deep cycle battery. Deep cycle battery is specially designed for to do the discharge to low energy level to the high energy level. The battery should be large enough to store sufficient energy to operate the appliances at the night or cloudy day. To find out the battery size, we need to calculate the battery size as follows. To calculate the battery size, there is the formula. For example, battery size is equal to battery size or the battery capacity in ampere hour total watt required per day by the appliances multiply nominal battery voltage